Okay, and you're going to use, this one, all of them out, and set this to AM, external mod index to be external, and range to be 0, and symmetry to be, calibration. Okay, just like that. Don't press any buttons. All that says AM. First, don't press it. So press the sine wave and get 1 megahertz. Okay, so it's pretty close to 1 megahertz. Okay, just the sine wave, and then get 200 millivolts, 100 millivolts peak. So it's 400 millivolts peak to peak in this case. Okay, and then basically you're going to go here. Frequency 110 megahertz. Okay, I think it is already preset. This one. Frequency 1 megahertz, and then you span 10 megahertz. Okay, then see that's DC, that's your signal you want. Center that it needs to be, and then span it using firmware so that you can notice what's going on. 10 kilohertz signal is going to be pretty close, so I'm going to span it to maybe 500 kilohertz to begin with, and then I'm going to span more later on. Okay, bring that to center. So that's your carrier frequency as it is, no modulation on it, and take the measurement on it. Peak surge, it should be minus 10 dBm, right? So you should, so basically take that. We had a cat, do you need to take all that?
I just want to watch it next time and understand. So.
I know. It looks like I'm teaching primary school here. Okay, so basically, okay, marker off. And now what you do is you're going to add the modulation. So for that you set up frequency 10 kilohertz, amplitude 1 watt peak to peak, and then go ahead, take that signal and put it to mod. Okay, now make sure everything is mod is external, this range is that, and now we are going to press AM here. Don't press any of these, that's internal modulation. So you should get something like that. You rescale it. Okay, first look at that. See that, go to single. You go to single, see that? That's the AM, nice AM mod index. And then measure the peak to peak. That's the V max, that's the V min. So that gives you the mod index basically for 1 watt. Okay, now we have to get the spectrum for that. So basically take that picture now, and you're going to take a picture here. Okay, you're going to span, because it's 10 kilohertz, it's pretty close to the carrier, right? So you want to span it maybe 200 kilohertz. Span 200 kilohertz. I need a little bit more. Span 100 kilohertz. 100 kilohertz, it might be drifting, so I had to watch it. Okay. So that is your carrier. That is basically what? 1 megahertz, and this plus 10 kilohertz, 1 megahertz minus 10 kilohertz. Just like FM, spectrum. So you got the time domain, you got the frequency domain. Any questions on that? And that should be 10 kilohertz away, and that's the height of that. That depends on the mod index. Okay, larger the mod index, the sideband come up. Okay, so you basically find the mod index, you make that table, this gives you mod index, that gives you the spectrum, and then you basically go amplitude to 1.5 volts. Okay, see that spectrum has come up. Okay, and then I'm going single here, see that? Mod index change. So when you're doing this, just do the time domain 1 volt, 1.5 as 2 volts, and then go here and go 1 volt, 1.5 volts, because you're going directly there. Any questions on this? Okay, very good. So the mod index, so I'm going to increase this to amplitude to 2 volts. See that mod index become very large. Okay, so you can see it's coming down. Okay, so that pretty much completes the part. That's the sine wave modulation. Okay, for these the other modulations, you're going to keep the same 2 volts peak to peak. That's nice. And then I'm going to go to triangular wave. Okay, so the same use the same mod index. You don't need to recalculate that because typically we use single tone to calculate the mod index. Okay, we kind of assume it's the same for the other ones. Although it's not quite true, but that's what we do. Okay, so let's see. I'm going to go triangular wave. So it should look like a triangular waveform. Okay, see the carrier frequency? Nice triangular waveform. Now you want to open this up a little bit more. Span 200 kilohertz. See that? That's the fundamental 10 kilohertz, 20 kilohertz, 30, 40, and all that. So base fundamental, second, third, fourth, because triangular wave has all of the harmonics, right? Okay, so you're going to see that. Okay, that's the spectrum now. Open this up, 200 to 300 kilohertz. And you want to open up 300 kilohertz. See that? Basically, that's your spectrum. Okay. Okay, now I'm going to go to square wave. Okay, and same, everything same. See that? How it is basically the 3 dB. I mean, it's sync function, but it basically you're seeing is the data is coming 1 0 1 0. So you're going to see fundamental, second, third, fourth, fifth, ninth harmonics, all of them there. So I'm going to change the duties. The last part is to change the duty cycle. You'll see the sync function nicely there. Okay, 50%. Now I'm going to go to, what's the duty cycle? 25%. When you're sending 25%, basically you're sending 1 0 0 0, 3 zeros. See that sync function? Okay, modulation, like remember the square wave has a sync function basically. Now with the 25% duty cycles, you see much better. That's the fourth harmonic goes to 0. So that now it's on the carrier. This is called the RF bandwidth. Okay, 0 0. That's the RF bandwidth. 1 2 3 4. You see that? Okay, that's the spectrum. Okay, so that's what you do today. That's pretty much all you need to do.